Okay, so now I'm start recording already. Recording. Right. Okay, so start with the first question. Okay, many of you do it wrongly. Yeah, did it wrongly. So calculate the magnitude of electric field. Electric field at point P. Remember, electric field is a vector. So vector, you must draw the vector diagram first. You must draw out the vector diagram. I didn't see any of you at all draw the vector diagram out. I didn't see any diagram. Yeah. So I don't know what you all do. Yeah. I really don't know what you all do. Okay. Can I say you are all dreaming? Maybe it's a appropriate word. What? You are really dreaming. What? So you see. Yeah. So calculate the electric field at point P. Calculate electric field at point P. So so you have negative charge, positive charge here. This is a vector. Yeah. Electric field is a vector. So vector, you must have a diagram, vector diagram. You need a vector diagram. You must draw the arrow. You must draw diagram. You must draw the arrow. So let's draw. Okay. So electric field at point P. So positive. Okay, positive charge. That means the electric field should go away from the positive charge. So this is E2. We label as E2 because this one refer to the Q2. And then Q1, you have E1. You should draw this arrow. I didn't see any of you draw arrow. You just straight away put in the formula, straight away add plus together. You do it assuming like you know physics. You don't know physics at all, class. So this is E1 and this is E2. You must draw the arrow. Yeah, I taught you already since the whole semester. I taught you the same thing. Yeah, but it just didn't stick in your mind. Whatever I taught, it didn't stick inside your mind. Yeah, this is the E resultant. So you have to find E1 equal to KQ1 over R square. You have to find one by one first. And then followed by E2 also. KQ2, this Q2, R2 square. So calculate one by one. What is K? K is 9 exponent 9. You can easily find this value in the list of constant. Q1, as I said before, this is a vector. This is a vector. So if vector, the charge ignore negative sign. The charge ignore the negative sign. If it is a scalar quantity like work done, potential, that one, the charge you must consider negative sign. But if vector, the charge ignore negative sign. So that means don't substitute the negative sign. Don't substitute the negative sign. Just put 10 micro. Micro is negative 6. Negative 6 coulomb. Yeah, micro, negative 6. So distance, how far is it? How far is it? E1, that means for Q1 to P. So how far is it? 7 cm. 7 cm means what? Change to meter. So 0.0, that means divide by 100. 0.07 meter. 0.07 square. Yeah. Do the same thing for E2. Do the same thing for E2. E2 for Q2 is 12 micro. Do the same thing also. 9 exponent 9. Yeah. And then 12 micro, negative 6. Yeah. And then distance 0.08 divided by 100, so square. So what is the answer? So find out the answer. Got the answer already. See, the same as what I done. No negative sign. This is the answer scheme. No negative sign. So this is the value. This is the value. So just write it down. I just put this just beside screen there so I can refer. So this is a 1.837 exponent 7, and this is 1.688 exponent 7. You got that value already. Now we need to find the resultant electric field. Remember, you must have the direction also, theta. But this one asks for magnitude only, no need direction. So how to find the resultant? I saw a lot of you, what you do, when you find the resultant, you just total up E1 plus E2. Is that the way, class? Do you just total up? Do you just total up like that? Why, class? Why? This is not what I thought. Wrong. This is got X component and Y component. So when you total out, you need to do Pythagoras theorem. What a lot of you do this E1 plus E2 straight away. So you should take this E1 square, because E1 considered to be the Y component, and E2 is the X component. So you have to do the Pythagoras theorem to get the resultant. To get this ER, the E resultant, or the resultant at P lah, resultant at P, resultant electric field at P. So what do you get? The answer is 2.49 exponent 7 Newton per Coulomb. Unit also. Many of you didn't put the unit here. Just give me the answer without unit. So careless. Then you get the correct answer. So this is the correct answer. The next one. Find the electric force. This time is what? Electric force. Electric force is what? Just like electric field is E. Electric force is F. Also vector. Force, if charge Q3 is 4 microcoulomb, is put at point P. So how do you find the force at Q3? Now I put a charge here. Let's say I put a charge here, positive charge. This one is Q3. So what is the force acting? What is the force acting on Q3? Do you need to do? Number 2. Do you need to? Resultant for this force is you need to do again, like F113 plus F23. So on. Do you need to do? No need. No need to do one by one anymore, because you already got resultant. Also, it's wrong. You cannot. I must also Pythagoras theorem. No need to do one by one anymore, because you already got resultant electric field. You already got a resultant electric field. So very simple. This one, just take the F equal to what? QE. So F equal to Q multiply E. F equal to Q multiply E. Straight away. This is a Q3. Q3 multiply the resultant. Then you get the answer already. 4 micro. 4 micro, negative 6. So this is 2.49 exponent 7. So what do you get? So you should get around 99.6 Newton. Like that. Straight away multiply the charge. Once you have resultant electric field, you can find the resultant force straight away. Just multiply by the test charge. This is what we call test charge. This Q3 is the test charge. Yeah, this Q3 is the test charge. Just multiply the test charge, then we get the resultant force. Understand not, class?
Yes, sir.
I wonder why you're wrong. This one, I say the charge ignore the negative sign. But when you consider like direction, you only put the positive negative sign for direction go up, go down. Yeah, for direction what? This one, direction go upward, positive, right positive, the left negative, downward negative. For vector direction. This one you need to consider the you only consider the negative sign for direction only. This one, yeah, I taught you before. You go back to chapter 1. Yeah, go back to chapter 1. Look at my video for this chapter 1. I taught this before already. Yeah. You only consider the negative sign when for direction only. I taught you before. The thing is, this one now direction is going to the right positive, going upwards positive. So no negative value is involved. If you have vector, let's say to the left, vector electric field to the left, then the electric field need to put negative. If you have your electric field to the right and you have electric field to the left at the same time, then you need to use the positive minus the negative. Understand? That means the right to the right one is positive, to the left is negative, so they become minus. That is what I mean. Consider the negative sign for direction only. For direction only. But for when you substitute the charge, you ignore the negative sign. I taught you this before. Just go back to chapter 1. Okay, so for vector, you need to draw the diagram. Draw the diagram first before you find the resultant. But for the next question about this one, about potential. Potential, no need to draw any vector. I'm surprised some of you do it like vector. Yeah. Potential is a scalar quantity. The following question is about potential. This is a scalar quantity. So this one, no diagram. No need to draw any vector. No need to draw any arrow. No need. For potential, no need. This one, of course, if you want to find the total potential, you just take V1 plus V2 on enough. Then this one okay. Just now that one, electric field cannot. Kalau electric field tak boleh. Electric field tak boleh. Ini mesti lukis vektor dulu. Ya. Kalau untuk yang potential boleh. Because dia scalar quantity, no need diagram, no arrow. Just total up only. V1 plus V2 only. So, okay. So this is the potential at point O. Point O. Just put at point O. So we have V1 and V2. We need to find V1 and V2 first. Find one by one first. V1 is apa? KQ1 over R1. Ini tak ada square. Some of you put square. Ada square lagi ya. Salah lah. So many mistake here and there. There and here. Here and there. Don't know what you all study ya. maybe when I'm talking, you are not really listening. You are thinking about something else. Yeah, your hand just, you are just moving your hand, copying the notes, and but your mind is passive. You shut down your mind at the moment I teach. I think that's what happened. So 9, this k is 9 exponent 9. Yeah. Q1 is what? Q1 is this one. This one is a scalar quantity. Potential is a scalar quantity. The charge must consider the negative sign. This one, the charge must consider the negative sign. Yeah, if the charge has negative sign, you must substitute negative. You must put there. Getting tired, you know. So this is Q1 is 1.2 micro. 1.2 micro. Micro is negative 6. Yeah. Negative 1.2 micro. Over what? 3 cm. 3 cm. So this is a 0. That means at the midpoint. No. This find potential at point S. S, not O. Not O. Is at point S. You want the S. So you must find the distance first. You must find the distance. Just now is this question. This one question correct. Yeah. This question is correct. Yeah. Find at P. This one find at S. So not O. So how far is it? This charge Q1 to S. How far is it? You must find. How? So you see, he say this is 6 cm, and he say here this is 8 cm. This is 6 cm. So that means this is 3 cm, 3 cm. So how far is it? Pythagoras theorem lah. You must find this distance, class. This is R1, this is R2. You need the R1 here and R2 here. R1 here, put here. R2 put here. R2. R1, R2. So how, class? How to find R1? Yeah, find cm. In cm you must change first. 0.03. Yeah, 0.03 divided by 100. What? Yeah, change to meter. 0.03 square plus 0.08 square. Yeah. So what is the answer? So I get 8.544 exponent negative 2 meter. This is in meter. I got it already. So R1 and R2 I think is the same. Yeah, this is the same as R2 also. So you will need this value later on. Yeah, you will need this value. So you will need this R1 or R2 put below here. Yeah, so just put below there. Yeah, just 8.544 exponent negative 2. Okay, so calculate. Calculate. What do you get? So you get negative 1.2. Yeah, what? Negative 1.264 exponent 5 volt. So what else? Yeah. So this one is V2. V2 is what? V2 is V2 then Q2 lah. Q2 1 exponent 1 micro. So bahagi ini, ya, bagi the same thing. So 9 exponent 9. So this is a what? 1 exponent negative 6. So the same thing here. Okay, so what do you get? 1.053 exponent 5. Then find the total V. Just total up V1 plus V2. Because this just scalar quantity. Scalar quantity, you just total up. No direction at all. No direction. Yeah? No need to draw any direction. Just total up. No need to draw any direction. So you just total up these two. Tambahkan. And you will get this answer, negative 2.11 exponent 4 volt. That's it. Yeah? The next question. Yeah? This this is question 1. Yeah, question 1, A, 1B. And then this C, a lot of you can do lah, because it's so easy question. Very easy question you can do lah. Easy question you can do. Hard question, not really hard question. Basic question also cannot do. But really, really easy question you can do lah. No problem for you, yeah. This question also very simple actually. Cannot do. Yeah. Cannot do. I don't know why you all write. Tadi tulis apa ya? Chapter 2. Almost every chapter also you have problems. Almost every chapter. Betulkah ya saya ajar setiap chapter pun sampai korang tak faham? Betulkah ya saya begitu lemah kah? Setiap chapter saya ajar kamu mesti semua pun tak faham. Itukah? I don't understand, class. A power supply of 12 volt which is connected to 3 capacitors, resistor, switch. When the switch S is closed, determine what? The time constant for the charging circuit. Find the time constant. What is time constant, class? What's the time constant? Time constant is this one, kan? Correct or not? Time constant is what? What formula again? RC, isn't it? So what you need is what? What you need is question 1. Yeah? Time constant. What you need is the resistance given 2000 ohm. Capacitor means the total capacitance. You need to find the total capacitance. Series parallel capacitor also, class, you have problem. Yeah? Don't know why, Basic questions. This 300 and 300 microfarad. So this first you need to combine all this. Yeah? You need to combine all this. Combine all this. Combine all this. Find the C equivalent. The equivalent means the total capacitance. So these two in parallel we combine first. Two parallel combine. What is the formula to combine two capacitors in parallel? What is the formula? In parallel? We total up, isn't it? Okay, label first. This one is 1, 2, 3. Put it as 1, 2, 3 first. Yeah. So I can say C23 equal to C2 plus C3. We total up because they are what? They are parallel. So this is total, you get 600 lah, isn't it, class? 600 microfarad. Then Then the 600 with the this one, then this C23 is in series again, series with C1. So I can find the C equivalent already. But this time is series. Series is 1 over C. 1 over C1 and 1 over C23. Yeah, this one in series. Yeah, in series. So C1 is what? 1800 micro plus 1 over 600 micro. Correct or not? Huh? So what do you get? What's the answer? Yeah. In the end, this is 1 over C. Remember, you must invert. Once you get it, you must invert it. Remember to invert it. Some of you forget to invert. You invert the answer. Yeah, 1 over C becomes C. That means this answer here you must invert. Then only you get the final answer, which is a 450 microfarad. Yeah, 450 microfarad. Okay. Nah, 450 microfarad. So okay, I got the C total already. So I can I find my time constant now? Can I? So easy. What's so difficult about physics? It's only difficult for students who are not really focused. So resistance is 2000 ohm multiplied by, this is, remember, this is micro. You have to change. Micro is -6. Micro is -6. Yeah, micro is -6. So once you change it, so I get the answer in 0.9. Okay, what's a unit for time constant? That one also students don't know. What is a unit for time constant? It's stated there. It's a time. Time. What's a unit for time? What's a unit for time? Second. That one some students cannot. Yeah? Don't know the unit. You know what he give me? You know what the student give me? He give me, okay, logic. He don't know what is the unit for time constant. You know what he give me? He say resistance is ohm, and then capacitance is farad. Oh, so the unit, he say ohm farad. How funny is it? Time constant is time. Yes, ohm farad is also correct. But don't you think it's funny to write ohm farad instead of second? Don't you think it's funny? Too funny? The time constant is second. What ohm farad? Okay, never mind. Enough. Yeah. So, what is the maximum charge stored in this capacitor? What's the maximum charge stored in all these capacitors? Maximum charge in maximum charge stored in 1800 microfarad capacitor only. What is the charge stored? What's the charge stored? Yeah. What's the charge stored? So this one, find the charge. This is series. First, you must see that. Okay, question 2. The Q total is equal to, because series, Q total is equal to Q1 equal to Q23. When series, they have the same charge. When series, they have all the same charge. Understand? So you must find what is the charge you want to find. Okay, so this is for 1800 microfarad, which is considered Q1. Yeah, this considered Q1. Okay, so if you want to find the charge for Q1, because 1800 is Q1, if you want to find the charge for Q1, you need to find the total charge, because the total charge is equal to Q1, because series, understand? So find the Q total. Q total. So how to find the Q total? So Q total equal to C total V total. So the C total is 450 microfarad. Yeah, 450 microfarad multiplied by the voltage, total voltage, maximum charge 12 volt. Okay, so what do you get? Now 5400 microcoulomb. So this Q total, this one will be equal to Q1 and also equal to Q23. Understand? This charge, the Q total of the whole thing is equal to the Q1 equal to Q23. Q23, that means the charge they get divided lah among them. Okay. So next, question 3. What's the time taken for the charge to drop by? Many of you get this wrong also. By. This one drop by, not drop to. This is a catchy word. Do you realize that? The time taken. He asked for time taken to drop. Drop, that means is drop. That means time taken for the charge to drop to 40% when the switch is closed. Actually, when the switch is closed, and then remove the battery lah. Yeah, actually should when the switch is closed and this one is when remove the battery. Yeah, when you remove the battery, then it start discharging. Okay, you should say remove the battery. Yeah, when the switch is closed and battery is removed. Yeah, the switch is closed and battery is removed. So the circuit is remains connected and the capacitor start to discharge across the resistor. So drop by 40%. Yeah, drop by 40% of the initial charge. So how to find? This is about discharging already. Discharging capacitor. Question 3. So this is about charging, discharging. Remember about charging, discharging, class? Charging, discharging. Many of you get the equation wrong some more. Charging, discharging. Do some revision. For this subtopic, charging, discharging capacitor, we concern with 3 quantity: charge, voltage, current. Charge, voltage, current. And we have 2 equations. Use 1 minus exponent and exponent. Do you remember which one use which equation? Remember that? Many of you don't remember. Yeah? If charging, which quantity increase? Do all increase? Do all increase? Yeah, class? Do all increase? Only the charge and voltage increase. Current decrease. Do you remember that? I taught you already. Discharging also all decrease. So you can see something here. For charge and voltage, for charging, they increase. For discharging, charge and voltage decrease. Charging, charge and voltage increase. For discharging, charge and voltage decrease. Remember that? Only the current decrease for both. Go back to your notes. Go back. Whatever you have copied there. I think whatever you have copied, you also don't understand anymore. Yeah. Okay. So charge increase, voltage increase. For discharging, they decrease. Yeah. So if increase one, we use the formula 1 minus exponent. The one with decrease, use exponent. I taught you this before. You forget. You forgot. Just simple as that. You forgot. Yeah. Charging is kalau meningkat punya, dua kuantiti ini guna 1 minus exponent. Kalau yang current walaupun charging, current menurun, bukan meningkat, menurun. Current kena guna exponent. Kalau discharging semua menurun lah, memang exponent semua. Ya. So tengok ini. Balik kepada soalan ni. Ini kata apa? Charging or discharging for question 3? Drop, he said charge drop. Charge drop means discharging. So dia guna formula ini. So formula ni adalah exponent. Formula ni exponent. Some of you write 1 minus exponent. Salah. Salah. So the formula should be what? It's about discharging. It's about discharging. It's about discharging and charge yang menurun. So it's minus, it should be exponent, not the one minus exponent. 1 minus exponent is only for increasing charge, for charging. Lupa sudah kan? Lupa sudah. Itulah saya suruh buat latihan. Saya selalu suruh selepas kelas buat latihan banyak-banyak supaya you ingat benda yang saya ajar. Tidak buat. Itulah. Tak dengar cakap orang tua macam itu. Ya? So itu charge equal to you. So the formula is use exponent. Charge equal to Q naught exponent negative T over RC. This so should be this one. Not kalau yang 1 minus exponent dia punya formula ialah begini. Q naught 1 minus exponent negative T over RC. Bukan ini. Bukan ini. Ada yang guna formula ini. Itu untuk yang increasing. Nilai yang increase. Nilai yang increase baru guna 1 minus exponent. Nilai yang decrease selalu guna exponent. Yang ini. Now, another thing here. He say this is about English. He say drop by 40%. Drop by 40% means what? Apa beza drop to 40% dengan drop by 40%? This one also you careless. Apa beza drop to 40% and drop by 40%? Yang atas tu drop tu ialah menurun sehingga. Ini menurun sebanyak. Apa beza dia? Apa beza antara sehingga dengan sebanyak? Menurun sehingga dengan menurun sebanyak. Apa beza dia? Tanyalah sendiri. Apa beza menurun sebanyak dengan menurun sehingga? Kelas? Kelas? Are you still there? Menurun sehingga ke menurun sebanyak? Ya? Soalan tanya apa? So menurun sebanyak ke menurun sehingga? Kalau menurun sehingga itu, maksudnya Q ialah, final Q ialah 40% of Q naught. Ini betul lah. Tapi kalau menurun sebanyak, drop by 40%, means what? Mean is 100 minus 40. Masih tinggal berapa? Sebab menurun sebanyak 40%. Masih tinggal berapa? Masih tinggal berapa? 60%. So, A lot of you write 40%, you know that? Padahal soalan tanya menurun sebanyak, bukan menurun sehingga. You write 40% for what? You should write 60%. Huh? So it should menurun sebanyak means masih tinggal 60%. Macam you harga discount 40%. Masih harganya kena bayar 60%. Betul tak? Dia hanya discount 40% saja. So this is 60% means 60 over 100. 60 over 100 Q naught. So it becomes what? 0.6 Q naught. So this is ini baru betul. Kenapa you buat yang salah tu? Ya? You tahu you lemah tak kelas? You tahu you lemah tak? Masih berapa hari nak PSPM? 12 hari saja. Ada 4 subjek. Bila? Berapa subjek? 4 subjek kan? Boleh ke rush? So, berapa hari? 12 hari. 12 hari bahagi 4 subjek means satu subjek 3 hari. 3 hari lah you cuba hadam semua. You're a big trouble lah class. So this one 0.6 Q naught. 0.6 Q naught. This is 0.6 Q naught equal to Q naught exponent negative T over RC. Ya? Yeah? So this masukkan Q naught. So 0.6 equal to exponent negative T. Where is the T? Time taken. Just now you got the RC already just now. You got the RC 0.9 second. 0.9 ohm farad. Funny, 0.9. So this is negative T over 0.9 ln E. Yeah. So what answer? Ln E is equal to 1. So you get lah. Fine. So you can find the time release. Very difficult. Do you think it's very difficult? How? Macam mana you cakap dia susah? Macam mana you cakap dia susah? Class. See that 0.57 second. So easy. You can get it. What's so difficult? Okay. What else? Ini pun. Ini. Lagi satu ini. Ini. This is Kirchhoff law. Do you know that this is Kirchhoff law? Do you know this is Kirchhoff law? Ini just very simple ni. Use a loop to explain. This is a question, the third question, yeah. Loop. So draw the arrow first, yeah. Draw the arrow. Draw the arrow. So this is negative to positive. This one negative to positive. This one direct. The EMF direction. Next, you draw the current. The current here. Current 0.3. Current. So current like this. Current pass through like that. Current. Okay. So current. This is the current. Current go through this one. This one. So how to choose? Just use a Kirchhoff second law. So this is the loop. This is the loop direction. Loop. So Kirchhoff second law. Remember? Total E equal to total IR. This question a lot of students cannot do. Also a simple question. You are too overconfident now, class. You are too overconfident. Yeah. So this one, you see this. So look at battery first. Battery. So E1 is positive or negative? Positive or negative? When same direction, positive lah. So we put this as positive E1. Now how about 15? 15 volt is loop direction is go to the left, but EMF is opposite direction to the right. So opposite kan? Opposite put negative lah. Negative 15. Okay, and then now no more battery. Now look at the resistor. Look at resistor. So we have 1, 2, 3, 3 resistor. So for resistor, look at current. The current same direction with the loop. This current same direction. This current same direction. So all current same direction. So positive. 20I positive. IR plus 15I also positive. And then plus what more? The 6I also positive. Because all same direction. All the current same direction with the loop. So positive lah. Okay. So this one I can what? Can factor out. So current 0.3 multiply this one total. What do you get? This one 15 plus 6 is 21. So 41. So 41. So E1 minus 15. So what is E1? What is E1? Yeah, what is E1? What is E1? So 27.3 volt. Nah, selesai. Dapat tu sudah E1. Senang. This is about one loop only. Just use Kirchhoff second rule. Kirchhoff second rule. Just one loop. Whenever we see got two battery, kalau ada dua battery, more than one battery, kalau ada more than one battery, we use Kirchhoff rule already. We use Kirchhoff rule. If we see more than one battery, we use Kirchhoff rule to do it. So easy can do. Got the answer. Physics difficult? No, it's easy. So that's all for today lah, class. Thank you.
Thank you, sir.
Thank you, sir.